Hello. Today we are going to learn about section 1-3, transforming linear functions. And when we talk about transforming linear functions, we are talking about moving a line either left or right, up or down, as well as stretching it and compressing it. So the first thing we're going to look at here is a horizontal translation. So when you think about a horizontal translation, you're moving horizontally. So you're either going to the right or to the left. So you're changing where it is crossing the x-axis, which will also impact where it crosses the y-axis, but you're thinking left and right. So when we do make this translation, I want you to take a look at this, I guess it's an equation or this function that I circled. What we're doing here is we are changing what we are putting into the equation. So if you look at the difference here between f of x, I'm going to kind of highlight that right here. So f of x is the function, and when we translate, you are going to be moving it by a factor of h. Now, when you translate horizontally, left and right, you are going to be entering the value of the translation with a negative or an opposite sign. For example, if we are going to go let's say 2 units to the left, so 2 units to the left, you would probably be thinking to yourself, well, 2 units to the left is going to be over here on the negative side. But you're always going to be doing the opposite sign. So 2 units to the left, we would write as +2. Versus 2 units to the right is going to be written as a -2. So you might jot down in your notes, opposite sign is what we're going to input. So if we continue on down here, let's look in this section right here. 2 units to the right, you are going to be entering f of x -2 versus +2. So you're always going to do that opposite sign. Okay. Now, before I go any further, here is the original line right here. F of x equals 3x plus 1. So when we do a horizontal translation, you are going to be putting whatever you're doing the translation of, it is going to go into the input. So just like it's written here, you're going to be doing f of x -2. Okay, so when you go ahead and do that, and we go back to our function here, we are going to be plugging in x -2 in place of where x would be located. So it would be 3 of x -2 plus 1. So when we do the math and we simplify, you're going to distribute, combine like terms, we end up with 3x - 5. Now, let's continue here on a horizontal translation. So 2 units to the left. So remember, if you're going to the left, you're going to be adding 2. And the reason we add 2 is exactly what's written right here. So when we substitute it in place of x in f of x, it's always minus the value. And so if we are subtracting a -2, well, that is where we get +2. So there's a couple ways you could think of it. You could think about the opposite sign, or you're always subtracting the number, which will end up being adding the number when you're moving to the left. So again, I'm going to be taking this x plus 2, and I'm going to substitute it right here. And then simplify, distribute, combine like terms. Okay, that is horizontal. Now, when we are working with vertical, I'm going to come through here and erase this. Oops. I thought I was going to erase it. Okay. When we're working with vertical, you are thinking about, I'm going to change color here. You're thinking about moving that y-axis or moving that line either up or down along the y-axis. So you're changing that intercept. So instead of, like we did over here on the horizontal, instead of plugging it in for the x in the function f of x, you're just simply going to add it or subtract it to the function itself, and think of it more as the output. So when you are vertically translating, you don't have to worry about the opposite. So if you're translating going up by 2, you're just going to be adding 2. And if we jump ahead to this one, translating down by 2, you're going to be subtracting 2. So when you translate up 2, your original function is this 3x plus 1. You're going to add 2, so 3x plus 3. So think of it as the original function here, which is 3x plus 1. The y-intercept here is 1, and your new y-intercept is 3 because you have moved up 2. Same thing on moving down. Your original y-intercept, 3x plus 1, is 1. And we want to shift down 2. That would put us down at -1. Okay, let's do a few examples here. Actually, I want to make this a little smaller. Okay, let's do a few examples. We are going to look at number 1. So number 1, of course, here is our function right here, f of x equals 2x minus 1. We want to write a rule for g of x. So we are going to be performing a horizontal translation 5 units to the right. So horizontal translations, you are going to be substituting in place of the x. So let me start here. So g of x is going to be equal to f of, and so my x is going to be changing by moving 5 to the right. And remember, we have to do the opposite. So when you move to the right, you might be thinking, well, that's positive on the x-axis, but we need to do the opposite when we substitute in. So it's going to be f of x minus 5. Okay, now I'm going to take this and I'm going to substitute it in for my function. So I'm going to have g of x equals 2 times x minus 5. And then minus 1 is part of my function. So now I can simplify, combine like terms. Make this a little smaller. So I'm going to be doing g of x equals 2x minus 10 minus 1. And so finally it's going to be g of x equals 2x minus 11. Okay, so that is a horizontal translation 5 units to the right. Okay, let's do the vertical translation. So vertical translation is moving up or down on the y-axis. So you're simply modifying your y-intercept. So g of x is going to be our function, f of x, and then we are moving down by 4, so you're just going to subtract 4. So let's plug in the value of the function. So g of x is going to be 2x minus 1, and then our minus 4 will take care of the translating down. So now let's just combine like terms. So g of x is going to be 2x minus 5. Okay, and that is our final function. Okay, next one, a vertical translation 3 units up. So again, vertical, I am modifying the y-intercept. So let's just start with g of x is going to be equal to f of x, and I'm going to be adding 3. So on vertical functions or vertical translations, you are simply adding or subtracting on the end versus horizontal. Right here we had to add or subtract within the f of x. Okay, so I've got g of x equals 2x minus 1 plus 3. And so now I can combine like terms. So my final function is 2x plus 2. Okay. And let's look at horizontal. So horizontal translation. I have to plug in place of the function. So I'm going to start like this. G of x equals f of, now I'm going 1 to the left. I'm going to go 1 to the left, so I'm going to do the opposite sign. So The left would be a negative, but I'm going to have to add 1 instead of subtracting 1. And really what we're doing, if we come over here to the side, we're really doing f of x minus negative 1. And x minus negative 1 is really plus 1. Okay, so g of x is equal to, so our function is 2x minus 1. So 2 times x plus 1, and then the rest of the function is minus 1. So my final function will read g of x equals, 2x plus 2 minus 1. So actually, my final function will read g of x equals 2x plus 1. Okay, so that is vertical horizontal translation. So the key here, horizontal, let me kind of go back to the top here. Horizontal translations, you plug it into the input. So f of x, I would have to substitute in what I'm doing in the input, and you're doing the opposite sign. Vertical, on the other hand, gets tacked on to the end because you're just changing your y-intercept. Okay, moving on to reflections. So reflections are similar to what you learned in geometry. So reflection across the x-axis is, if your x-axis, of course, is right here, when you reflect over it, if we start above the x-axis and then end up below it, you are simply changing your y. So if you look at what is written here, it's negative times f of x. Versus across the y-axis, you're maybe starting here, and then you're going to flip over to this side, so your x value is changing. So we are changing what is getting substituted in for the x. Okay, so let's look at this first example here, reflection across the x-axis. So our rule is going to be g of x is going to be, across the x-axis here, I am changing my y. So it's negative f of x. So g of x is going to equal, my rule here that we're looking at is this 2x minus 1. So I am going to be having a negative, parentheses, 2x minus 1. So my g of x will be negative 2x plus 2. Okay, now reflection across the y-axis. I am doing g of x. So across the y, my x will be changing. So it would be f of, and in the parentheses, negative x. So g of x is going to be 2 times negative x, parentheses, and then my function is minus 1. So g of x will be negative 2x minus 1. Okay, and so that will represent a reflection across the y-axis. Okay, I'm going to pick up the last page of notes in a second video. So if you would go ahead and find that other video, we will finish up this section for notes.